guys hear me?
Yes.
Loud and clear? I'm just trying to say it to grab your attention anyway. How are you guys? How's everyone doing? Well, thank you guys for coming in for the July edition. So we've got some machine learning stuff for you today. And we've got our brilliant presenters from DataStax and AWS coming in. I would want to give a special shout out to DataStax because they have sponsored us this event, so we are very, very grateful. And we look forward to having you guys in the future as well. So, let's quickly look at the agenda. So, we'll be starting off with Hilton, who's going to be talking about AI in real time. He's got a pretty interesting demonstration for you guys, so get ready to, what to say. I'm pretty sure it's not an interactive one, but then I did see him doing some coding, so there's something going on in this, I don't know what that is, but either way, something interesting. And then it will be followed by Tommy. Tom Liu is the technical account manager at AWS, so he's also going to be talking about ML ops using Amazon SageMaker, and he'll be going through some best practices as well. So, after that, we'll be ending the session with food and drinks, where you guys get the chance to network with each other and enjoy those delicious pizzas, which will be arriving very, very soon. Alright, so without further ado, I will hand it over to Hilton. The podium is yours, mate, and let's have fun. Cheers. Sorry to bother you, Hilton. Before that, yes, you guys must have noticed this. So it's a $600 giveaway. So anyone who wants to enter to the draw, you can find those white papers on the desk. It's just a simple barcode that you guys need to scan. Cheers for that. And we thank DataStax because of whose sponsorship we were able to get this giveaway to you guys. So don't worry, it's okay, you'll get enough opportunity. Be aware, the draw will finish at 7:15, and I will be announcing a random winner through the software, whatever that is. So, please, in the meantime, if you guys can scan, please scan, and then we can go from there. Cheers, thanks. Over to you.
Thank you.
I'll use this one. All right, good evening, everyone. Yeah, I want that too. Can I, am I eligible?
You guys are the one giving it away.
We're also giving away corksicle mugs. Now, these are great mugs to keep your coffee warm or your cold drinks cold. I use them on my desk all the time. And those, I've only got 3, so I'm going to give them away to people who ask interesting questions. So we look forward to hearing those questions from you. My name is Hilton. I'm a pre-sales solution architect at DataStax, and I've got a background in IT operations management, automation, a bit of coding, used to develop iPhone apps and that sort of thing. And these days I'm doing a lot with data and machine learning. So today I want to talk to you about real-time AI, and we're going to define what that is for you, where most organizations find themselves today with AI, and how that's different to real-time AI. Now, as Annie said, I have been digging around in some code, so I've got a demonstration to show you, and we will look at the code and how you can train a model on AWS. We're not going to get too deep into it, just touch on the surface. But the main thing I want to get across to you today is, what is this thing we call real-time AI? Before I get going, just by a show of hands, who is doing anything with AI at the moment? Okay, fair amount. Who has not used ChatGPT? Right, you guys are trailblazers. Who has heard of Find, P-H-I-N-D? P-H-I-N-D, a website called find.com. Spelled P-H-I-N-D, no? GitHub Copilot? SageMaker. Oh, that gets the most hands, awesome. So my SageMaker is going to look very primitive to you then. All right, thank you for that. Does this sound true? It seems that everyone's talking about AI, and there's a good reason for it. But I read a very interesting book called AI 2041. It's a piece of science fiction written by a developer from, dare I say, Google, and a science fiction author. And it's all about where they see, the two of them, AI landing us in the year 2041. What sort of things will we be doing with AI? Very interesting. But everyone wants it, so we need to relate to it. Uber, one of the pioneers in AI, because they employed the people to do it many, many years ago, skilled them up and spent a ton of money developing a lot of AI capabilities. Now these guys, are we recording? Oh, okay. I was just going to say maybe I can go without the microphone. I'm speaking too close to it. Is that better? Okay. Thank you. More. Okay. That's better? Perfect. All right. Thank you. I just like my voice, I guess. So Uber, they use AI for everything. You know, when you order an Uber ride, the price that you get is set dynamically, real-time dynamic pricing. How do they plan which driver is going to come and pick you up from all the drivers that are in the vicinity? It's quite obvious that they're using a lot of AI. Some of it's real-time, and we'll get to the definition. Some of it is more not real-time, in batch, but they take into account a lot of information. For those that want a more technical look at how they do it, they do something that's called a lambda architecture. Lambda meaning a split architecture. So there's two lines here. There's above the grey line, online, and below the grey line, which is offline. We can think of offline as traditional AI that most of us would do today. We collect data, we transform that data, we extract features, we train a model, and we make predictions based on that model. But that model might be a month old, a year old, and the predictions that we're using might have been made a month ago, a week ago, a year ago. It's not actually in real time, is it? With this architecture, what Uber do is they mix in real-time data that's streaming in from Kafka. And you can see it there. It comes in from Kafka through a streaming engine and lands up in a feature store. In other words, that streaming engine is extracting features from the real-time data and dumping it into a feature store. That feature store is based on Cassandra. Cassandra is the same database that DataStax is built on. In fact, we're the biggest contributors to the Apache Cassandra project around. And then there's a real-time prediction service. So each time you open the Uber app, you're getting the most up-to-date prediction they can make based on real-time data that's streaming in. Real-time data from the driver, real-time data from the rider, real-time traffic data. All of these are coming in real time and augmenting the offline model. So what this means is we use a model that we've trained offline, but we want to make predictions in real time as the data's coming in. There's no point that when you ask for a ride on Uber, that you get a ride based on data from 2 hours ago, is there? That would not be very good. So I'm going to dig into this offline, online, or real-time batch AI a little deeper by looking at how we talk about real-time AI. So this is the bottom half of the Uber diagram. It's very small, I know. I'll read it to you. Sorry about that. Further away, sorry. On the bottom in batch, essentially we collect the data, we extract features, we train the model, we make predictions, and we store the data in a prediction store. And then the application on the right-hand side in red, that application is asking the prediction store for predictions, but those predictions are old. We don't have any real-time data coming in. The other way to look at it, and the difference here, is that now we have real-time events streaming through on the top row, just like Uber did. Those then go into a real-time prediction service, which can be SageMaker, it can be TensorFlow running on your laptop, which is what I'm doing, or it could be any other machine learning service that allows you to run inference calls on a model. So the bottom line is all about training the model, the top line is all about using that model in real time. A little bit more on this topic. Where have we come from? We've come from a world where we collect information. We collect tons of information. We probably collect far too much information. But what do they say? Data is the new oil, right? So applications would generate a lot of data, and we would collect that raw data, we would parse it, and we would store it in a data store. Anyone care to tell me what that data store is called these days? Sorry? Data lake? Yeah, data lake. Database? Yeah, it's a database. But generally, the big term that people use is data warehouse. Or these days, who said data lake? I think you get a corpsicle. Yes?
Lake house.
A lake house. Can you define a lake house for us?
Lake house is a data lake where you store structured data like a data warehouse, but it's more scalable.
Yeah, yeah. It's kind of like a combination of a lake house and a data warehouse, hence lake house. Yeah, I think we'll pay you the corpsicle on that because you got the data lake. We were looking for either data lake or data warehouse. Thanks, Annie.
Thank you.
So we store all this data, and it grew into a data warehouse, and then it grew into a data lake. Then we decided we need to be able to do better analytics on this data. So along comes the data scientist. And what we've added here in the green row is we've now created a box around it called feature extraction, right? Feature engineering. So the data scientist is trying to understand what aspects of the data are best suited to make predictions about something. That's the essence of machine learning. And those features, if you follow the green line to the right, get dumped into a training and test data database, which then the data scientist works with to design models and train the models. The trained models are then dumped into a model repository. The other lines, the orange lines moving up, those are about once the models are trained and validated by the data scientist, then it's time for any useful features. So the data scientist usually will work with a feature repository. He will define the features and the transformations that go with each feature, store them in the feature repository, and all of the calculated features, extracted features, are stored in the feature store. It's a very roundabout way to get the features into the feature store. But what we want to be able to do is we want to be able to get the data going directly from the data store to the feature store. We want it to go directly from the green to the red without having to go through the model development process. Because the data scientist has already defined the features, so we can just add a line here where the data, as it streams through your application in real time, the data goes directly into the feature extraction process. Now, to do that, we generally need a stream processing engine, and we need access to the feature store and the feature repository. We transform the data and we store those features. That's what's missing between batch AI and real-time AI, is that green line. The other thing that happens, once we've got features, features alone is not valuable. What's valuable is the ability to use them and to generate real-time predictions. So we add the blue line, and I'm going to show you a working demo of this blue line. What that is, it's a real-time API. Essentially, we need an API that can work with the model and real-time features. We want to be able to feed in the real-time features in terms of Uber. That's the current driver location, the current traffic conditions, the request I've made for the ride I want. Those are the real-time data features coming in. And then Uber somewhere has a real-time API, an application online, that your mobile phone sends out a request to that API, and the API says, this is your driver. That's the blue line. It's the ability to make a prediction using the model in real time. But of course, we need to constantly improve our models. And Tom is going to talk a lot more about the life cycle of machine learning and the need to go through all of these phases in more detail, especially the model monitoring, the purple box on the screen, because I need to make sure that the predictions and features that I built last month are still performing this month, that they're still relevant to what I'm doing. So we need a way to store the data, and we need a high-speed database to store what we call the prediction store. Every prediction we make from our model, we need to store the results in a database so that I can feed those back into the training process to update the model and retrain the model. Okay, that's it at a high level. Hope I didn't bore you to tears with that one. Any questions on that before I continue?
Was that Uber system the Michelangelo?
Yes, the Uber one was Michelangelo that they developed. Yeah. So for those that don't know, Michelangelo is the AI platform that Uber developed for themselves, and the only people capable of doing it in the last 10 years before it became so accessible to all of us would have been organizations like Uber, because they had the resources to do it. Uber, Facebook, Google. Yeah.
What happens if the business rules change and prediction store would have to also change as well?
Yeah, so if the business rules change, that's a really good question. What happens if the business rules change? How do the predictions remain relevant? And that's where this monitoring of the model falls in, because I need to constantly make sure that the way the data scientists define the model and the features that are used with the model are still relevant to the business problem. If they're not relevant to the business problem, then there's no point using it. So we go on an iterative process. And I think Tom is going to talk a bit more about that machine learning lifecycle.
Question.
Yes.
So data and numbers are something that if a data scientist gets their hand on it, they can make the numbers talk, or data talk in a way that they want it to be. So how do you ensure that the raw data that you are feeding into the stream cycle is relevant raw data and not something that is kind of biased?
Okay, there's two, well, the minute you raise the word bias, it changes the question a little bit. So I need to clarify. Are you asking how does the raw data get transformed into the type of data that the model needs, into features, or how does the model not become biased? How does the model not become biased?
Based on the data that is being fed to.
Yeah, it's an interesting dilemma, and it's an ethical debate around machine learning. Can a model be biased, and how to prevent it being biased? And of course a model can be biased. Let me give you an example. I'm not going to go too deep into it because it's not the focus of our talk today. But let's say I want to predict, well, let's take ChatGPT for example, right? That ChatGPT, you can ask it to write some text for you about something. But if I ask it to write a song about my next door neighbor, is it going to default to assume that my next door neighbor is Native American, Indian, or Indian from the country of India, or Fijian Indian, South African Indian? In terms of, it doesn't know, it's going to make an assumption, and when it creates the data, it's essentially going to do it on the data that it was trained on. It's going to create something for me based on the data that it was trained on. So if I train my model on data that is biased, the outcome from my model will be biased.
So how do you stop that bias from coming in? How do you ensure the checks and the audit?
I don't have a good answer for you. It's way beyond the sort of thing that I'm looking at the moment. I would say the best avenue to follow with that one is to do some research on the ethics of machine learning. That's the whole subject that it falls into, and how data scientists need to ensure that the data and the parameters that they elect to put into their model don't bias the model. It's a whole separate field. Yeah.
I'm a beginner in all the data science stuff, but with features, in real-time AI, are they dynamically chosen or something like that?
Not chosen, but calculated.
Right.
So generally what happens is the raw data flowing through your system is not the same data that you'll feed into your model to make a prediction. It's not the feature ready. You need to transform that raw data, aggregate it, transform it, augment it.
But a person does that?
No,
Oh,
no,
okay.
a stream processing engine does that.
All right, okay.
Right, so the data scientist will define the features. Each feature, when it's defined, will have a definition, what it is, what it's used for, but it will also have all the code needed to transform it to essentially to create that feature from the raw data. You might find that some of the raw data comes from 10 different data sources, which are then joined together, stripped, cleaned, and then fed into a single feature to feed into the model. So that code to do that data transformation is part of the feature definition. So as data flows through in real time through the system, you need a high-speed data store to store all that data, and a high-speed stream processing engine that can pull all the data together, transform it into a feature, and store it in the feature store ready to use. Does that answer your question?
I guess so, yeah.
Yeah. Suffice to say that the machine learning model takes as input features, but features are not the raw data. The raw data has to be transformed into features, and we want to do that in real time. That's the whole thing about real-time AI, is doing that feature transformation, extracting the features from the raw data in real time.
You mentioned monitoring function is basically, its function is to observe the model and make sure that the model is will behave. How do we know if the output of the model is like, for example, the price that the person should pay to the Uber car to go from point A to point B? How do we know if that model price forecast is actually accurate, is meaningful?
So how do we actually implement model monitoring in terms of validating that the model is performing correctly? That's the question. How do we actually validate that the predictions the model are making are sane, for want of a better word? That's really a whole separate business process. I myself, I don't know too much about it. Maybe Tom can talk a little bit about it, because I know that some of the SageMaker toolset has tools to help you with that. So let's leave that one for Tom, I think.
The rejection ratio, like people who see the price, if they accept the price or if they don't.
Yeah, so all of that's going to be input into the process on validating how the model's performing. Okay, I am going to move on in the interest of time. Thank you all for your questions. Is anyone doing anything like what I'm talking about today? Is anyone interested or have a use case to do this sort of thing? For those that are, please feel free to come and have a chat afterwards. I have a colleague of mine here as well, Hugh, over there, and the two of us will be sticking around later, so please do come and talk to us and see how we can perhaps help you. All right, I don't have much time left, but I did want to show you this working. So we're going to do a little demonstration. You'll notice that I just zoomed through all the slides there. Now, the demonstration has a couple of components. First of all, what it's all about. Anyone use Netflix or Hulu or what's all the other ones? There's a few of those other ones around. I don't know what they were like. Was that Stan? Yeah, that's it, Stan. You know when you go into your Stan or your Netflix and it tells you, we reckon you should watch these movies. It's making recommendations for you. It's telling you what they think you should watch. Netflix also invested a huge amount in AI and built a recommendation engine that based on what all the users around the world are watching, they reckon they know you better than you know yourself and they can tell you what to watch next. So I'm going to show you how they do it. And to do that, we have a web application, which is essentially the Netflix front end. We have an API in the background, which the web application is talking to, and the API is the real-time API, the real-time prediction API that's able to make AI predictions in real time. The API is talking to my model. The model is trained previously in SageMaker, which I'll show you. And then we're running the model on my laptop using TensorFlow. So the API talks to TensorFlow, gets a prediction back. It also needs to store the result of that prediction for model monitoring purposes. We spoke about the model monitoring, and I need to store every prediction that I make with the inputs, features that went into that prediction, and the prediction result, so that I can go back later and check that it's still valid. And then the result gets returned to the web application. But I've got this running in two versions. I've got this running in one version that it's in real time and in one version that it's batch. So let's have a look at that. Okay, is that coming up on my screen? Okay, I'm going to make this as big as I can. Can we see this up the back?
Yep.
Okay, so the system I'm working in here, by the way, is Amazon SageMaker Studio. SageMaker Studio, just like most other machine learning platforms, operate essentially as a Python Jupyter notebook, right? So you write your Python code and you can execute it with comments and text and documentation inside the notebook. For the purposes of this exercise, I'm running a single virtual machine, a single instance. It's got 4 CPUs, 16 gig of RAM and 1 GPU. And the different notebooks that I'm running are running inside of that kernel. So it's a very simple training set of code. What it works with is some data that comes from the Movie Lens database. Movie Lens is a publicly available movie recommendation database, and essentially what it has is for every user, the user ID in the left column, the movie that the user watched and what rating they gave it and what time they did that rating. So they have 10 million data points in this data set of different users around the world, what movies they watched and what rating they gave that movie. And we're going to use that to train the model. Yeah, make sense? Okay, so back to the code. I need to load a bunch of Python libraries, modules. Now I need to load that data set into a pandas. Can anyone tell me, is it pronounced pandas or pandas? Anyone? Pandas, okay. I don't know, because the first time I came across it was I read it, no one said it to me. All right, so we load the data into a pandas time frame, which is just a nice way to work with CSV data or tabular data. And if I execute it, this command here will show me the first few lines of the table. So there we are. As you can see, I'm running this live for you, okay? No tricks. So it reads the first few lines from the database. Now, with machine learning, we want to split the data. So I've got however many rows of data, but I want to split it because when I train the model, I need to use some of the data to train the model on and some of the data to validate how the model's performing, okay? So we're going to split it into two sets of data, training data and testing data. And then these print commands will tell me how many rows I have in each. So my training set, I'm only working on a subset here because I don't want this model to take hours to execute. I want to be able to do it in the lab today. So my training data has 80,000 rows and it's 4 columns wide. My test data is 20,000 rows and it's 4 columns wide. Now I'm going to define the model. This is a deep learning model, and it has multiple layers like all deep learning models. So it has a couple of input layers, which we define here. Don't worry about this too much. When it's done, it'll show you a summary. We create some embeddings so that we can understand the data. Embeddings are a way of plotting data to find similarities in data. That's one way to think about it, a way to find the similarities in the data. So we do that one, a couple of dense layers, and here we define the model itself and what sort of loss operator I want to use and what sort of optimization I want to use, and then we're going to print a summary of the model. So here's the summary of the model. We haven't trained it yet, we've just defined it. And what it's showing me is all the different layers in this model. So we created 2 input layers, we created a few embedding layers and flattened them, we created some dense layers. All together, from the 60-odd thousand rows of data, I've created 525,377 parameters to train the model on. Now, just to give you some context of how tiny that is, can anyone tell me how many parameters ChatGPT version 3.5 was trained on?
Is it 300 billion?
300
Billion?
billion? 80 billion, 600 billion. Okay, who's going to Google it for me? Sorry?
170 trillion. 170 trillion?
173, you Googled it?
Yes.
Or we still guessing?
175 billion parameters according to ChatGPT.
How many?
3 or 4? 175 billion parameters.
175 billion. Let's give the man a mug. This gentleman over here. We live in a world where we don't guess, we check. All right. So that's 175 billion. I'm only doing 525,000. We're kind of, teasing ourselves here. All right. To train the model, I'm just going to define a few variables, and then we use this command model fit. Model fit, it's a funny word, but essentially it makes sense when you understand the mathematics, because training a model is all about fitting a curve to a set of points. That's one way to think about it. If I've got lots of points, what's the best curve to fit all those points? So we're fitting the model to the data. And then we're going to save that into a file. Alright, so here it goes. And it's running. Now I'm doing it over 10 epochs. What it means is 10 iterations, and each time it runs through it should get better and better and better. The model should learn, you know, deep learning, and it should get better. So the way to tell how it's going is through this attribute loss, the loss value. Not the val loss, the loss value. Sorry, it's just because of the zoom on the screen. Can I make this bigger? There we go. So the first loss number, it's decreasing, yeah? So after 10 epochs, it's down from 0.0427 to 0.0289. So the model's now trained, okay? Now what we're going to do is we're going to make a prediction using the model. So all I'm going to do is I'm going to define a function to make a prediction from the model, and what I want the model to tell me is what movies I should watch next and how many movies I want in that recommendation. So I've got a line of code here that says get user recommendations for user ID number 1, 5 recommendations. If I execute that, I get an array or a set of the 5 movie IDs that I should watch next. Now that's all well and good, but I need a visual interface to use it, right? What I need to do is make that into an API. I've got to finish, I'm out of time. I've got to make that into an API that a graphical interface, that a web interface can use. Just to show you how that works, and then I will be gone. So here's my web interface. Okay, it's showing me movie recommendations for me. But I can operate this, I'm just going to zoom in. You can see down the bottom here I've got a button on the bottom left, batch or real time, because my API is smart enough to operate in batch mode or real time mode. The thing is, if I operate it in batch mode, every time I reload it, I'm going to reload it, it gives me the same recommendations. Now let's say I just go and I watch Little Nicky, the middle one. I watch Little Nicky and I give it a rating, and I come back to my ratings, my recommendations, and I reload it. Oh, I'm getting the same recommendations. Why? Because I'm not. Why?
The model's fixed.
The model's fixed, yes, that's not so important.
Historical data.
Sorry?
It's giving recommendation from the historical data what it has done.
No.
It's looking at the data. So the recommendations will only change when the new batch process is run. Until then,
Okay, so it's not actually a function of the model's training.
It's looking at the data which people have looked at more and more. So it's taking that particular model and it's predicting that you will want this particular data.
Yeah, it's exactly right. The model is trained on the only data that the model has in its training is this. All it knows is the user ID, the movie ID, and the rating. It has no sense of what did I last watch. If I watch a movie now and then give it a rating, how can this data set know that? It can't. So actually what I need is I need to add some columns to this that I can then feed in real time. I need to change it a little bit to be on the right hand side. I've added 2 new columns. Every time when we train the model, I'm going to now tell it what was the last movie I watched, the movie ID, and what rating did I give it. Then I'll retrain the model using that data, but still the model will still be the same. I'm not going to use a different model. Every time I use this model, it's the same model, but when I use the API, I'm going to feed in the last movie that I watched and the rating I gave it, and that will generate a new prediction. So if I show you that,
It's still not personalized. If you think about it logically, you need to personalize it for the customer.
I'm sorry?
It's still not personalized. If you
Oh, it's absolutely personalized because every
because you're not matching the data with the same category of people who are watching the same kind of things.
well, it is because it has user ID. There are multiple user IDs in here if you have a look. Okay, so it is aware of what different users are doing. Let's talk afterwards because I need to clear the stage. Please come and see me afterwards and I'll give you some more information on that. But if I retrain the model and tell it each time the last movie I watch and the last rating, then when I recommend a movie here, so right now, if I use this in batch mode, I'm not telling it what rating I give. Each time I come here and I give a rating, it shows me the same thing. If I switch to real-time mode, what I'm doing now is I'm now passing in the actual rating that I give. In the previous one, let me explain. In the batch mode, I'm not feeding into the API the rating that I just did. What I need to do is feed the rating that I just did into the API, which I do by selecting real-time AI. And now when I choose a movie, now it changes. All I've done is fed into the model the last movie I watched and what rating I gave it. And each time I do that, it's going to give me a different prediction.
You're also feeding in the choices that other people have made as well.
That's to train the model, because the model needs to understand what's the world thinking.
If you give your time, you're also doing that as well, aren't you? Like there will be other people watching movies at the same time.
Yes, the API is doing it for every user, and that's why you need some serious performance. On the 17th of July, I'm running a hands-on workshop where we're going to do this. So if you want to come along and see how we do it hands-on, please feel free to come along. It's just here on York Street in the city, and we're going to go through that line by line and show how we do it with the API code and the ML code.
Do you have the code on GitHub?
I'm sorry?
Is the code on GitHub?
Yes, you will be working with the code from GitHub. You'll be able to clone it from GitHub onto your laptop or into your own repo, and then you'll work with SageMaker and actually train the model yourself. All right, I've got to get off because I've got to make room for my colleague here. Thank you everyone for your attention, and please come and see me afterwards for questions.
Fantastic, very good presentation from Hilton. Tom, I'll hand it over to you immediately. And just for, I do understand that it might run a bit late, but after 7 o'clock, please feel free to go grab your pizzas because the presentation is on the big screen as well. So you can actually hear the presenter saying stuff there. So I do know that, you might get a bit hungry, but yeah, I mean, as soon as the pizza's here anyway, so after 7 o'clock, please feel free to jump off and yeah, we can go from there. Tommy, I'll hand it over to you.
No problem. I think I can use this one. See for me, so everyone can see it clearly. Hi everyone, my name is Tom Liu. I'm a technical account manager for enterprise support ops, and especially I specialize in machine learning. I've been doing the field training to help customer to learn our AI ML services, public event also. There is also a coming one on, I think on 27 this month. I was trying to share the info with Annie, and maybe he can share that one for you also. So I see some sort of interactions, very interesting. We may pass some question in between, may not necessarily clarify the so-called model monitoring and some sort of bias detection also in this section. May talk about it later on. And when the pizza's ready, if you feel hungry, feel free to go out to grab the food, and don't blame on me that if I run a little bit, over time. And other than that, I also want to ask a couple of questions to understand a bit better about yourself. How many people here are doing DevOps or ML engineer ML engineering today? Okay, a couple of them. A bit shy today for the gentleman. Not a problem. So I hope that this section may help you understand a bit of like a journey from ML experimentation to productionization. And if you have no idea ML as of now, like for example, you're from a software developer engineering background, I may do a very quick one-on-one to help you understand a bit. And then in today's sections, like with that journey, I want to help you understand what important and why ML ops, and potentially help you understand like in SageMaker, our ML platform, what's the services you potentially be interested if you want to jump in and you leverage the platform to boost your productivity, especially for your data science and ML engineering team. Okay, so the agenda for today, we will start from a use case. Hopefully that might be interesting to you, and then we'll talk a little bit on practices and SageMaker services. I won't go to too much detail. If you are interested in learning more, feel free to reach out, okay? Now let's start with a use case. Now, buying your dream house. Okay, raise your hand who don't want to buy their dream house. Okay, no. So the use case here today is about that you have certain K budgets and you want to buy a dream house. Let's say it's a 2-bedroom, you name it. And location-wise, potentially maybe like a 60 minutes train to city or so, pretty decent. And of course, like potentially you may be able to talk to real estate agent or check out the such as domain or the other website to understand the market pricing stuff. But I would say that like let's don't access those websites, don't Google it, and I will give you a bunch of past history data. Yeah, data again. Now this time it's a house pricing data. You may imagine that on a suburb for certain room, bedroom, car space, backyard, or storage. Like that kind of information, and potentially maybe what kind of view, those are the raw data for the house pricing data. And if you want to buy the data to make a decision that, hey, if I want to check out the market and where should I go, then potentially you also have a problem that, hey, if I'm going to go for an inspection, do I really waste my time and do I really finding something, checking something potentially I can pay for, which comes up with a problem that you want to estimate a bit on the price. For example, if you have 500K, for example, you probably wouldn't go to Chatswood to find a 2-bedroom, right? Yeah, you potentially may be going to somewhere, right? So this is kind of the problem. Yeah, so when we try to analyze this kind of problem, we actually put in a bit data head on ourselves, doing a bit of analysis, and terminology-wise, usually we call it so-called data analytics. But backed by that, we also can use some sort of machine learning techniques to tackle the problem. Now let's tackle the problem now. The first problem is to understand what potentially I can buy. Just assume that the data set is authentic. It's the the recent data, and especially the last couple of years. There may be situation that COVID changes situation a bit and Reserve Bank changes the situation a bit, but don't worry too much about them. And to understand that, who can do SQL or who can use Excel? Can you please raise your hand? Yeah, awesome. So if you have that data set, you feel excited because you may have a certain budget such as 500K. Then in the filter, and Excel filter functions, you can set up the filter, maybe around 400 to 600. Those set of data will be something you're interested, and then you can check against the filter result to understand where is the suburb, what's the room size, and total size, how many bedroom, for example. This is something you begin with. Of course, you also can use SQL if you are really want to get hands-on, and writing SQL query. It's kind of the same thing. You are doing the query against a rectangular data set. And other than that, the right-hand side is about a visualization dashboard, which you call. And dashboard, in a sense, is basically to help you to transform the data, like numeric number, to be picture. It can be pie chart, it can be, whatever you can into, such as some sort of bar chart or whatever, for you to histogram, to help you understand, plot the data, understand the nature also. Like, these two is basically like a data analytic common toolkit. So it can help you to understand where you can buy your house. Now the next problem you potentially want to solve is about, hey, I want to predict the house pricing. This one, I don't need to tackle a difficult problem like Hilton. He's tackling a movie rating problem at real time. But my one, I potentially just get the recent data and then I'm ready to go to train a model. And then I use the model to get some hints. And why prediction may matter as a buyer? In the sense that if they open apps, Saturday morning at certain hours, you only can do it by yourself or maybe with your partner. And you certainly can only go to a certain location. You don't want to go to a location potentially it doesn't make much meaningful for you, as I say. And potentially there can be other use cases. Now this is ML 101. The basic idea on machine learning training a model basically is it's a inductive way on getting insight, and terminology we also name this so-called inference. Inference is not something that you deductive the reasoning, such as such as like US dollar is green, and then $1. This note is $1, so the note must be green, something like that. It's not something like deductive. Inductive, in a sense, is basically you have a set of data, and you have the so-called label, and the label in this use case, on the pricing use case, is the so-called price, the house price. Okay, and the way you train the model is basically you have the historical data, and you're feeding into an algorithm. And this algorithm will train a so-called model for you, no matter whether it is so-called statistical one or deep learning one. And this model, there is no difference, like basically no big difference than the program you're writing. The only difference is about that program is backed by explicit rule. Like you can say so-called heuristic rule style, you implement your business rule. But with machine learning training, you basically just use some method to train a program, and that program can be used to get insight on the real time or real life data. That's basically the idea. So this is so-called like label. There will be other ML problems such as unsupervised, but the problem we are talking today, or like even for Hilton's one, is basically supervised stuff. You have a label on your data set. Okay, now if I'm going to use a data set to train a model, like Hilton already showed an example. He have a notebook open in Studio, and then he has a process, and the process is basically start from loading the data, then doing a bit of feature engineering. Now what is feature engineering? Basically the idea is that what really matter like to your problem, right? For example, to a certain extent, maybe a housing problem sometimes like they don't provide the distance between the location to city. But for transferring that, because one of the criteria is 1 hour or something, right? And then potentially you may using some writing some logic to convert the geolocation associated with the nearby train station, and then check against the travel time in between, and then you will get the duration on the train traffic. So this is so-called feature engineering. And once you have that, you will like split the data and then train the model, evaluate the model. Once it is good, then that's super awesome. You're ready to go. You have a model, and that model potentially is about your, for this Saturday, you're gonna use it. How are you gonna use it? You may check on the online, and then you can base on the, the posted inspection, the open inspection days or so of those property, feeding the detail and then feeding into your model, you will get some insight about, hey, how much approximately they are. Of course, like we don't talk about the, how great the model performance here. We just imagine that, oh, you train a great model here and potentially can be used in your use case. Now, this is so-called ML experimentation. Experimentation, what's the focus? The idea is that I want to validate the idea. I want to see that if I have this set of data, whether I can drive insight from there and train a model and can benefit my business. Yeah, that's a so-called experimentation. Now, moving on, what's the challenge on experimentation? This is the list one. The most tricky one is experimentation period, you mainly focus on the idea. Potentially, maybe you will work on the data, transform the data to be useful features. Or potentially, you may want to figure out the right good algorithm for it. It can be, you can try along with whatever will suit. And this kind of the effort you can put on. And however, to do that, being a data scientist or a machine engineer, you work on that kind of problem, you certainly need some sort of toolkit. And having those kind of toolkit is not easy, especially for data scientist team. We need some sort of consistent environment setting. We want to potentially not just CPU resources and GPU resources, I would say. So this is kind of the challenge also, and to a certain extent, company also facing a data security, governance issue as well. So it's kind of tricky. So with that said, I also want to talk to you in regard of what SageMaker services potential can offer. So the offer on top of that is basically we provide the notebook or the build environment for data scientist team. At the left-hand side, you can see that that is so-called a typical way you run everything on your machine, no problem at all, as long as it works. But very tricky is about that it's your environment, and it can get polluted, accidentally or by purpose or something like that. And it causes an issue that it's not consistent across on your team. And when you're working in a team, it becomes a bit of chaos to work together to get a same sort of baseline or so. Yeah. And those kind of baseline can include the software, hardware also, because to some certain extent it may be backed by GPU. And with SageMaker offering, basically there are three types of, certainly you can build something on EC2, but with SageMaker, there are sort of three types of offering. One is so-called SageMaker notebook instance. That's kind of managed notebook environment backed by EC2. It's directly when you provision a notebook instance, you pay as you go. Use that instance types for certain hours, you pay for the storage also. And the next one is about, it is SageMaker Studio Lab. Studio Lab, if you use Collab, pretty much is kind of similar environment. You provide a free ML environment for your experimentations. It supports CPU and GPU. So I don't use that very often though. Notebook and Studio Notebooks. Studio Notebook pretty much is the environment Hilton just demo, and that environment pretty much, well, talk about that right away. It's more friendly. It's a purpose-built ML IDE on cloud, and it's it includes a lot of integration. It's backed by Jupyter Hub, Jupyter Lab environment. All right, so I want to do a quick intro. This one is notebook instance. There is no big difference than the EC2 instance though, but it's a managed services for you. Everything kind of set up, software packaging, and it also supports you to do your customizations. You create your environment or your runtime. In Jupyter environment, we name it so-called kernel. And with Studio, basically it's more user-friendly for data scientists in the sense that once you provision Studio domain in your account under region or so for dedicated team, you can set up how you want to access it, backed by IAM, which Identity Access Manager, or is it backed by identity center, which is a centralized access control environment. And once you provision the domain, what it's trying to back up to you is like you see a console like the ID environment just now, but basically you can choose what types of kernel you want to use. Kernel in a sense is basically like a runtime environment, such as you're doing some sort of like statistic like machine learning problem that can be scikit-learned, or you are backed by certain deep learning frameworks such as TensorFlow, MXNet, and the PyTorch also. Then you can choose that environment, and also you can choose the underneath infrastructure such as those compute resources, CPU, GPU types. So it depends on your need. You gain those flexibility, you just click the button on the ID environment right away, and it can do the job for you. Yeah, that's the service. Now back to your use case. All right, so our housing price prediction model works so well. So now we think big. We want to like build an application for that and potentially like benefit all the folks joining the event tonight. So what we're gonna do, which means that we will potentially need to deploy a model in the environment, and then we will have a sort of maybe web application or a mobile app to serve the purpose, for potential user to use it. Now to do that, like basically the idea is that you build it and then you run it. Everything's perfect. And like Hilton just demo, there is a situation that you want to do real time, but there is also a situation that like if you don't do real time, but you can just use the model right away, not connecting to the customer's input. But what you're trying to do here in your pricing model deployment is about that, hey, potentially if Reserve Bank change the interest rate tomorrow, then it may change a lot on the real estate market, right? So that's kind of a situation. Or there is another like lockdown for some sort of virus, and then situation may change. So this is kind of the real life. So the model you're using today, or you back by the historical data, but when situation change in real life, then potentially the model will be stale. Then you can't trust it for your use case, right? So this is the challenge. And also like for this challenge, you other than that, like doing the model deployment is not easy. It's sometimes very tricky. And in software industry, what you are doing now today is very standard. Like potentially you have CI/CD, you have packed like CI process to do the integrations, and you also build like maybe Docker container or like Docker image, and then you can ship it and run it on a container platform. Like that sounds super easy. And for ML, it's not that easy as of now because it's a very cutting edge emerging domain, and there is a lot of effort being spent on like how to improve the efficiency of model deployment, and especially inferencing is not cheap. Like for example, if you read some news about ChatGPT spend, like each request or so is spending like 0. something dollars. It's not cheap. So how you guarantee that you are actually using right infrastructure to back by your environment? So it's not easy. Now from the engineering perspective, this slide pretty much helps you understand. At the left hand side, it's about experimentation. So the most focus is about the data, the code to do the data engineering and feature engineering, and the other half is about the algorithm, like how you create the algorithm for your purpose. So it's all about experimentation and the idea. And then the right hand side is about operations. Operations that is more than that, right? For example, you want to standardize it from data. There is a process until the data is ready to feed in to train a model, which so-called is like data pipeline. And then train a model, then potentially you have your like algorithm for that, and usually we pack it as so-called like model pipelines. And also like when you deploy that, it's so-called inference, and inferencing is so-called inference pipeline. And for this part, there are so many engineering effort across. It's not trivial. Of course, if you are just doing your like house price prediction model, simply you can just run it anywhere, not a problem. But when you are facing the real customer's request comes in, then there are more than that, like engineering effort, operation effort. And to do that, so basically the very typical practice, like what we mentioned earlier, is about that there are two important parts, actually three. Like I said, data and building the model and then deploying the model, right? This is kind of three parts. But here, what we are touching is across a bit on the first two merging together with automated. Like in a notebook environment, you execute the notebook, run it right across the cell, and you at the very end you get a model, right? But in real life, you can't always ask someone, to click the button for me on a certain time, right? You want to have a mechanism to automate that process and generate, train the model for you. And on top of that, you also would like to have some sort of full end-to-end to manage the challenge, like end-to-end in the sense that if data being changed, then maybe you want to trigger the new model training, or the algorithm the code being changed, you want to trigger it. And on top of that, potentially, there is services for you to feed in, the feedback to certain process and retrain the model, or maybe notifying your team to review something. So this is kind of a general process. And to put it, to put a nutshell on this one is basically you create a flow and then you create feedback loop and you have a mechanism to look after that. Yeah. And this part is so amazing, but for data scientists team to tackle them, again, it's not easy. So you're gonna do a lot of heavy lifting across on how you're going to prepare your training environment, like package also consistent on your model algorithm and the others also. Yeah, so given that it is not easy, we have service for you, which is SageMaker. And what we want to tackle here is to help you understand a bit okay, now we understand that we have pipelines in our life cycle. We understand that we want to automate them. We also want to put in feedback loop. Now, what can we do here? Basically, we have a services, the purpose-built SageMaker pipelines. Pipelines basically a service. I would say that it's kind of one of the core service to orchestrate the flow on cloud for a customer, and it supports a bit on running app local, not full function, but maybe like a cloud native as of now. And there is some beauty about them here. But one thing I do want to call out is about that it has an orchestration engine and it's highly integrated with AWS services. If you have data, today on S3, data layer, whatever, then potentially this can be ideal for you to, accessing your data easily on cloud and tackle the problem. And these are the three components under SageMaker pipelines. I'm going to talk a little bit about them. So basically, the first one is so-called the pipeline component. I sometimes get confused. SageMaker services has a pipeline services. That sounds very confused. But basically, just imagine it is an orchestration engine, like a workflow engine to help you to orchestrate the step. Now, talking about orchestrate step, you can see that there is a direct cyclic graph here. Basically, the idea is a workflow. A general workflow being listed here. You have a data set on S3, it's kind of raw data, and then for the training process, you're going to process the data, doing a bit of feature engineering, and when the data is ready, you will train a model back by it, and you're going to evaluate whether the model's performance suits your needs or so. Because this part is important because you train a model for business, you don't train it for fun. And if it is a good model, you can set up a condition and then you can trigger action. Maybe you will keep that model in the so-called model registry. Now, there is some services back on them, such as SageMaker Training Job, which is our larger scale distributed training environment. If you embed them in SageMaker Training Job or processing job on top of the process, it just make your life easier and decouple your ML process. And the next service I want to talk about is model registry. Model registry basically it's a metadata report for your model versioning. why this important? Now I have a use case before that my customer basically they keep the model versions by Jupyter Notebooks versioning. So you can imagine that they change the algorithm, for example, and then they will keep a version. And if they want to roll back, they will just find out that notebook and then run it again and get a model. If you work on ML before, that sounds so funny, yeah. And but basically the idea is like you may need to repeat something you done before, like compute resources, for that. It's not worthy. And on the other hand, maybe you have an Excel file, you want to record down what model being validated, what's the performance, and which one being deployed to production. That's not ideal as well. So with model registry, you can capture the metadata of your trained model version. And in that sense, you can roll back easily. And these services pretty much, when you hook it up in your SageMaker pipeline lifecycle, so it actually gives you a chance that a human in the rope process, like human in the rope in a sense that you can use it to verify the model's performance on whatever data set you like, other than the auto mechanism. And with that, it will give you more like a higher, quality assurance, and it allow your data scientist team to, back check some, important model or so. And this is a UI for you to understand like how they look like on studio environment. And last is about the project. So SageMaker projects pretty much is being designed that there are two main purposes as far as I can see. One is the end-to-end CI/CD pipelines. So we have the orchestration engine, and then we have the model registry. Now this one has a CI/CD end-to-end. What does that mean? That means that from the source to the end, for example, you can look after them on the whole life cycle. From the source, the data change of the algorithm change, you can use it to manage, the model training process. And if you train a new model, you put it into model registry, and someone verified it and is happy with that, they approve the model, and that can trigger an event so that they can, kick off a deployment pipelines to deploy the model in a certain environment. That's how it works. And this is just a console. The console, on the second benefit I want to call out, is about that if your organization, have a data scientist team, they potentially tackle some ML problem, very likely. They have this similar process. Then potentially you don't need them to, create their own, every time start from scratch. And projects in a sense that you can customize your template, and they can just use that template to create an ML workload project, and with that they can customize a bit and then ready to go. That's how projects help your organization to scale, reuse your existing ML process or template or so. Yeah, so this is kind of the beauty on that. Now, lastly, I want to do a quick summary, and also if maybe we can jump on to the pizza, and if we have questions, we can do further discuss. So I want to help, in the summary, I want you to understand that what we are trying to do on an ML workload project is mainly we want to drive the business value from there. So there must be some useful data you want to refer to, and then learn the data representation with a mechanism, and potentially once you have that, you can benefit your business. This is one thing I want to call out. And in the whole life cycle, there are basically two stages. The first stage is ML experimentation. So it's more on ideas. Studio give you some flexibility on choosing, your build environment. And the next hop is about productionization or operationalization. That's currency focus. It's about engineering effort. Potentially your team want to invest, and the consistency of the environment or so you want to choose or so. So with SageMaker, the pipeline services embedding integrated with other services such as the training job, processing job, and model registry, it helps you look at the life cycle. It also has the lineage checking also to benefit your ML team data scientist team in their journey. So yeah, that's overall I want to cover. Any question, we can just go out to talk about them. Okay? Thanks for your time.
All right, thank you so much, Tom. Thank you all for your patience. I do understand that you guys must be hungry, so I will not stop you a second more. The pizzas are ready outside. The only thing that I wanted to say is I do understand that there's a lot of people who came in a bit late, so they didn't get the opportunity to win this. What I'll do is while you guys are having your pizzas, I'll just put the barcodes on the projector out there. Scan it. Simple question, and you can just go away with a cool smartwatch. Either way, guys, thank you so much. It's been lovely. I will let you know when I'll be announcing the winners. Cheers, guys. Guys, there are some swags as well available. You've got this webcam, some useful stuff here. Feel free to grab them.
No, so he kind of sold that business off. He started this BI cloud service called Site Manager. So that kept him busy for a while, but now he's kind of looks up for himself. Yeah, working with
That's what he always wanted. He always wanted to set up a business.
Guys, if you see the projector screen here, you can find the barcodes. I'm still giving you the opportunity. It's open for the next 10 minutes and then I'll be closing it. So give it a shot. Cheers, guys.
Yeah, it was no problem. Feel free to pass.
Yeah, it's good. I have software development. It comes with the journey. My